So our next problem is check whether the number is power of 8 or not. Okay. So I hope you have already watched my previous lecture on power of 2 and power of 4. So if you have already watched those lectures, I guess you can do this problem. Okay, you can do this problem as well as power of 16 also. But still, if you want to watch this, I'm teaching you. Okay, so we'll check whether my number is power of 8 or not. Okay, so let's take the example. Let's say, what is the power of 8 raised to power 0? It will be 1. What is 8 raised to power 1? It will be 8. What is 8 raised to power 2? It will be 64. What is 8 raised to power 3? It will be 64 into 8. Okay. Okay. So we'll follow the same approaches. We have followed 3 approaches in the power of 4 problem. Okay. So we'll follow the similar approaches in power of 8 as well. First approach is by taking the modulus with 7 and keep checking. Okay. So let's discuss the first approach. So let's take my first approach. So I will check. I'll take number and do mod with 8. So if it is not 0, okay, if it is not 0, it means that it cannot be power of 8. Okay, and if number mod 8 is 0, then I will check further. Okay, so what I will do, again same as power of 2 and 4. So let's say it is 16. Okay, so 16 mod 8, it will be 0. So I will divide my number by 8. So 16 divided by 8 will be 2. Again, I will do 2 mod 8. 2 mod 8 is 2. So it is not a power of 8. Okay, and let's take 64. So if I take 64 mod 8, it will be 0. So just divide my number by 8. Okay, my number will be 8. And again do the same thing. 8 mod 8, it is 0. So again divide my number, 8 divided by 8, my number will be 1. Okay, and as soon as your number reaches 1, it means that it is a power of 8. Okay, simple one. Keep dividing. Okay, keep dividing your number until your mod is 0. Okay, so you can write while your number does not equals to 1. Okay, check if your number mod 8 equals to 0. If it is not 0, return false from here. Okay, otherwise do number equals to number divided by 8 and keep doing this. Okay, and at the end return true. Okay, it is a pseudo code, you can correct this right now. So what is my second approach? My second approach is similar to my second approach of power of 4. Okay, that's why I told you, if you have covered power of 2 and power of 4, you can easily do power of 8 problem. Okay, nothing is different, all patterns are same. So in power of 8, first I will check if it is a power of 2. Okay, if it is a power of 2, then only I will check further. If not, return false. Okay, it is not a power of 8. So it is not a power of 8. If it is a power of 2, then I will check further. So what I will do, I will check number mod number mod 7 equals to 1. Okay, if that condition satisfied, it is a power of 8. If no, it is not a power of 8. Okay, so let me take some examples. So let's say 64 only. Okay, so 64 is a power of 2. You can write it as 2 is to the power of 6. Okay, so it is a power of 2. Now check further. So 64 mod 7, what it will be? It will be 7 9 is 63. So it is 1. That means 64 is power of 8. Okay, if you take another number, let's say if you take 16. Okay, So 16 is the power of 2. 16 is the power of 2. You can write 2 is to the power 4, right? Now check further. 16 mod 7. It will be 2. So it is not equals to 1. It means it is not a power of, it is not a power of 8. Okay. So this is our second approach. Now the important one is third approach. So our third approach, it is the important one, okay, because that will check your bit manipulation logic. Bit manipulation logics. Okay. Again, it will be same as my third approach of power of 4. Okay. So what my idea is, now let me write it 1, 2, 4, 8, 16, 32, 64, 128, like this. Okay. Now my 8 power 0 is 1. 8 raised to power 1 is 8. 8 raised to power 2 is not 16, 64. 8 raised to power 3 is 5 and 12. Right. So what I will do, I will mark the bits where these values can be possible. Okay. So if I extend this, it will be 256 and 512. Okay. So I will mark this here. Power of 8 is possible. Okay. Here power of 8 is possible. Here power of 8 is possible. Here power of 8 is possible. Okay. Now if you observe carefully, see, we have first bit where power of 8 is possible. Okay. And after skipping 2 bits, every third bit, okay, every third bit is power of 8. So from here, first is power of 8, fourth bit is power of 8, seventh bit is power of 8. Okay, like this. So at a gap of 2 bits, every third bit is a power of 8. Okay. Okay, that's what we need to find from the problem. Okay. So my first bit is power of 8, fourth bit is power of 8, seventh bit is power of 8, 10th bit is power of 8. Okay. So for this, what I want to do, I want to do AND with my mask such that it will give me 0 if it is a power of 8. If it is a power of 8. Okay. Again, I'm repeating, if my number, so let's say my number is 512. 512. Okay, I'm taking big number now. So it will be 512 and all zeros. So it will be 512, 256, 128, 64, 32, 16, 8, 4, 2, 1. Right. Now I want the answer as 0. Okay. I want the answer as 0 if it is a power of 8. So 512 is a power of 8. Okay. I want to create such mask such that I will give, it will give me 0. Okay. So what if I take here 0? If I take here 0, it will give me 0. Okay. And what other bits are possible? So this bit and this bit, this bit, these bits, at these bits, power of 8 is possible. Okay. So I will mark all these bits as 0. Okay. In my mask, I'll take all these bits as 0. In power of 4 also, what we did, wherever the power of 8 is possible, we'll take the bits as 0 in this mask. Okay. Now rest write like 1 only. Okay. On rest, take 1. So this will be our mask. Okay, this will be our mask. Now if you extend it, if you extend this mask to 32 bits, why 32 bits? Because integer have 4 bytes, which means 32 bits. So if you want to write this mask for 32 bits, I need to extend it. How I can extend it? So let me write the mask in 32 bits. Mask in 32 bits. Okay. So from here, from last, every third bit can be power of 8. So put 0 at every third bit. Put 0 at every third bit. Put 0 at every third bit. So if I write my mask in 32 bits, I can write it like this. Okay. And again, it is not a good idea to write this whole. So convert it in hexadecimal. Okay. How I can convert this in hexadecimal? So I can create a group of these 4 bits. Okay, and I can write the hexadecimal value. So it is 1, 2, 4, 8. It is 6. Okay, and it is 8 to 1. It is 11. So it can be written as B. Okay, it is 8, 4, 1. So it is 13. It can be written as D. So again, it will be 6. It is P. It is D. Again, it is 6. It is B, and so on. So my mask will be B6D, B6D, B6. Okay, and it is hexadecimal. So write 0x. Okay, it means it is hexadecimal. This is my mask. Okay, now how to find whether the number is power of 8? So I'll do number and with my mask. Okay, and if it is 0, it means it is power of 8. Okay, and if it is non-zero, that means it is not a power of 8. Okay, before this I will check the condition of power of 2. Okay, so my combined condition will be check if it is a power of 2, check if it is a power of 2, and bitwise end with mask. Okay, it should be 0. Okay, or you can write this condition same as this one. Okay, this is nothing but logical NOT. So if you write this, it is same. Okay, both are same. So you can write power of 2 and your logical NOT with and mask. Okay, this will give you whether the number is power of 8 or not. Okay, similarly you can do power of 16 as well. Okay, so first two approaches you can do power of 16. Okay, first two approaches you can easily do. Okay, first approach is just take the modulus with 16. Okay, and perform the same operation. Second also, just take check whether the number is power of 2 or not, and number mod 15 equals to 1. So second approach is this one. Okay, in third approach, let me discuss the third approach. So in third approach, let me write 1, 2, 4, 8, 16, 32, 64, 128, 256, 512. Okay, now what is 16 raised to power 0? 1. Again, 0 is not power of 16. What is 16 raised to power 1? It is 16. What is 16 raised to power 2? It is 256, I guess. 16, 16. Yeah, it is 256. So if you observe this, 1 bit, it can be power of 16. Okay, it can be power of 16, and it can be power of 16. Okay, so at these bits, just take 0 in mask and rest as ones. Okay, and you can convert this in hexadecimal, right? So if you write 0 triple 1 0 triple 1, this will be easy. 0 triple 1. So every time your mask will be 0 triple 1 in form of groups. Okay, so if you write this, it will be 8 4 12 2 14. 14 can be written as E, I guess, right? Okay, so if you write this, your mask will be 0 triple 1 8 times. So it will be E 8 times. So it will be E E E E E E double E. Okay, 3 6 8, and you can write it at 0x to identify it as hexadecimal. Okay, so this can be your mask, and again your final condition will be check whether it is power of 2 or not, and do your number and operation with your mask, and if it is 0, then it is power of 16, otherwise it is not. Okay, so this is also I have almost done it. Okay, so any problem, see, the most important one in these kind of problems were this third approach. Okay, so if any problem, let's say now next problem came as find whether the number is power of 32 or not. Okay, so just perform these operations. Just put this. Okay, your power of 32 can be here, can be here, can be here. Okay, and create the mask accordingly. So main important task is to create the mask. Okay, while creating the mask, I used to put like 0 at those places where the power is possible and ones at those places where power is not possible. Okay, so you can do a vice versa of it also. Okay, it is feasible. So my mask was 8. If you revert the bits, okay, your mask will be different. Okay, so do anyways you find comfortable. Okay, why I used to take like this? Because I want my answer as 0 if it is a power of the particular number. Okay, if it is a power of 16, I want my answer as 0. That's why I'm taking 0 in the bits where the power is possible and 1 at the bits where the power is not possible, so that I can get 0 when it is a power of 16. Okay, I hope you understood it. If not, just please watch the lectures in sequence. Okay, power of 2, power of 4, power of 8, okay, then power of 16. So it is enough. Till here is enough, right? No need to do further. So in interview, they can start with finding power of 2, then they can ask till power of 8 or power of 16. So mostly power of 4 and power of 8, they stop. But even if they extend to power of 16, you can find. Okay, so this is all about this problem. And time complexity, I guess you know, right? So if we are doing one operation, it is order of 1 only. Okay, and at max in bit manipulation it goes till order of log n. Okay, if in any problem it is going beyond log n, that means you are not optimizing your bit manipulation logic. Okay, so this is all about this problem, and let's move forward to next problem.